Okay, so I've shown you how the Richardson extrapolation can be used to combine two lower order solutions to get a solution that is of higher order accuracy. But if you want to keep on deriving different solutions to get higher and higher order accuracy, you're going to end up with lots of equations, and it's going to be mathematically quite complex to do. So fortunately, the Romberg integration method is an efficient way for us to implement the Richardson's extrapolation. So the techniques that you have seen over there, the way we combine the two equations to get higher order approximation, can be generalized by using the Romberg method. So the generalized Romberg integration formula is given by this equation over here. So in this case, J and K are represented by this table here. Okay, so J is given by this column here, and it has values of 0, 1, 2, 3, and so on. Okay, and K here moves to the right, and it starts again from 0, 1, 2, 3, and so on. Okay, so as we move down the table, this is called the Romberg table. As we move down the table, the J value will increase. What an increase in J value means is every time we increase the J value, we are doubling the number of segments, or we are halving the interval, or we are halving the size of our H. Okay, so if you think of J equals to 0 as representing one single segment when we carry out our integral from A to B, then when we move on to J equals to 1, we are doubling the number of segments. We're using 2 segments. When we move to J equals to 2, we are using 4 segments. J equals to 3, we use 8 segments, and so on. Okay, so every time we move down or we increase J, we double the number of segments. Now, the first column here on representing K equals to 0, it represents the solution that we get from the trapezoidal rule. So R00 basically means that what is 0 for J? It means that we use one segment. So when we do R00, we are using one segment or one application of the trapezoidal rule with one segment. If we move down to R10, we are doing trapezoidal rule with 2 segments. R20, trapezoidal rule with 4 segments. Trapezoidal rule with 8 segments, and so on. So all the values in this column here, you can obtain it by manual calculation. Either you do your trapezoidal rule manually, or you can, when you write an algorithm or when you write a numerical coding method, you can use the recursive trapezoidal rule, because when we move down, we double the number of segments, and that allows us to use the recursive trapezoidal rule to come up with a very efficient way to perform the trapezoidal rule. So the first thing to remember is this column here is the only calculation that you have to do using numerical integration method. Okay, and this is done based on trapezoidal rule. If you move on to this column, this is known as the Simpson's one-third rule. But take note, this is not, or the values that you see here, these are not calculated using the formula of Simpson's one-third. Instead, what Simpson's rule here suggests is that the accuracy, okay, before that, because we are doing trapezoidal rule here, the accuracy of this column is of order h squared. Okay, we already know that the accuracy here is of order h squared. When we move to the Simpson's rule column, what Simpson's rule here means is that the accuracy that you get from these solutions here are of order h4. We know Simpson's rule has order of accuracy of h4. So these solutions mean that you have a solution that has accuracy of order h4, which is similar to the Simpson's rule. And how do you get all of these solutions here? You are going to use this formula. So for example, what is R11? R11 would mean that K equals to 1 and J equals to 1. So you're just going to substitute J equals to 1 and K equals to 1 over here. If you substitute that into the general formula that you get, you're going to get 4 times R10 minus R00 divided by 3. This is what you get when you substitute K equals to 1 and J equals to 1 into the general formula. And what you can see from here is that you need to take 4 times of R10, which is a solution of your trapezoidal rule using 2 segments, and you minus off with R0, which is a solution of your trapezoidal rule using 1 segment, and you divide by 3. This formula is the same as the formula from the Richardson's extrapolation rule that we have. So if th represent one segment, this would be two segments, correct? And you can see that you have 4 over 3 of the two segment minus 1 over 3 of the one segment. So this is the idea behind the Romberg integration. You're just combining two solutions of lower order accuracy to get a higher order accuracy using the formula that you get from Richardson's extrapolation. So if you have R11, this is what you get. But if you move one move down, if you have R21, then you would have R21 is equals to 4 times R20 minus 4 times, minus R times 10 divided by 3. So the formula is still the same, it's just that we are using two different approximations of the trapezoid rule. Okay, the formula will stay the same in the sense that it will have 4 and 1 here and 3 at the bottom, because that is a formula that we get when we combine two trapezoid rule to get a better solution, or with an accuracy of order H4. Okay, so what you can see from here is, in order to calculate R11, you need these two. In order to calculate R21, you need this. To calculate R31, you need this, and so on. Okay, when you move to k equals to 2, this would have order of accuracy of H6. Okay, so the way to calculate R22 would be similar. In order to calculate R22, you need these two values. Okay, so how do you calculate R22? You're going to replace J2 and K2 into your general formula. So if you replace this with 2 and 2, you get R22 is equals to 4 to the power 2, which is 16 R21 minus R11 divided by 16 minus 1, which is 15. Okay, so to calculate R22, you have this. And you know that R22 would have an order of accuracy of H6. To calculate R32, you will have this. To calculate R42, you need these two. But before you can calculate R22, you need to calculate R11. And how do you calculate R11? You need these two. And how do you get this value here? You use trapezoidal rule. So you can move on to the column to the right to keep on finding the solution that is of higher order accuracy. That is the idea behind the Romberg integration. So as you move to the right, the accuracy will increase because the order of approximation improves. At the same time, if you move downwards, the accuracy will also increase because the step size is significantly reduced every time you double the number of segments. So in the lecture notes, in one part of it, I've shown you how you can actually apply the Romberg integration formula. So please go through that to get an idea how you can use the Romberg integration to carry out numerical integration.